Good afternoon, Sanbonani. Hello, guys. Welcome back again. Thank you so much for supporting the channel. It's really growing. If you haven't subscribed yet, please subscribe. Make sure you click that notification button so that it can tell you when we're back. Today, we'll be doing some revision, some question based on grade level Euclidean geometry. We'll be applying now all of our theorem on what we know, on what we have learned based on our theorem. First thing that you need to know, or first thing that you need to do when you are going to answer this question. Now, as you see, you don't see any question underneath this diagram, because it's not the first thing that you must do when you are going to answer these types of questions. There is this statement here and there is this diagram here. First thing that you need to do, you must read this statement before you come to this, before you come to the question. Why? Answers are here. If answers are here, so if you can first read this statement, try to connect the statement and the diagram before you come to the question, then you will need the question, because answers are just going to come here before you coming to answer the question. So let's first read our statement step by step, our statement step by step, correlate it with the diagram, then we'll come to the question after that. What is the statement saying? In this diagram, O is a center. Okay, if O is a center, O is a center from theorem 1, theorem number 2, and theorem number 3, if I'm not mistaken. There are things that are being said about O is a center. So if O is a center, somewhere, somehow, we're going to have what? Some radius. O is a center, somewhere, somehow, angle at the center towards the angle at the circumference is going to be there. So now, if O is a center, we know from O to the circumference, that is a radius. For OA, it's a radius. OB, it's a radius. OC, it's a radius. OD, it's a radius. All of those things are radius. So you can just write that OA equal to OB equal to OC equal to OD. All of these things are what? Are just radius. So this equal to this equal to this equal to OD is equal to this. All of these things are just radius. From what we have just written right now, there are many things we can find in terms of angles. Just saying O is a center and finding this radius. So now, if OA and OB are what? Are radius. Now this one is equal to this one. What does that mean? It means that O1 is equal to angle B, what? Isosceles angles opposite equal side. From just that, and again, this and this triangle, this one, OC and OA are my radius. That meaning O2 is equal to OA2 is equal to C2, what? Angles opposite equal side. We are analyzing a diagram. We haven't answered any question. And then now also this triangle here, OD no OC are my radius, then they are equal, meaning this angle here, which is D, is equal to what? The whole C, which is C1 plus C2, what? Angles opposite equal side. Just analyzing a diagram, just being O is a center, nothing else. So now I hope you see this thing. I hope you understand it. All these angles are equal. A1 just O being a center. And again, there is this shape of being always a center. Always a center. This angle here is equal to this angle twice. Angle at the center is equal to twice the angle at the circumference. Remember, this theorem, it's 3 times. There are many diagrams of this one. There are 3 times of this diagram. There is this one that we usually know, this one that we usually know, that this one we usually see that one. There's also this one, and there's also another one. So now in here, see this diagram from here is this one, but it's just on the other side, the flip side of it. So this angle here, which is O1, is equal to, now not this one, 2 times what? C1. Angle at center is equal to 2 times the angle at circumference. Angle at the center is twice the angle at the circumference. Just O being a center. Just O being a center. Now move on with our statement. We're done with O being a center. Analyze, look at the angle that we found, just O being a center. Now they are saying A, B, C and D are pointed at the circumference. A, B, C and D are pointed at the circumference. These are just pointing the circumference. Do we see any cyclic quad there? No, because these here are not, there is no line that is joining them that make the whole thing being what? A cyclic quad. Sorry, a cyclic quad. Then let's move on with our statement. And then now of a center and CD. Now they are telling us that CB, it's what? It's a diameter. It's a diameter. What does that mean? Now if this is a diameter, I hope you remember that angle at the angle at the semicircle. If we have this, we have the diameter, and we have a triangle that is forming here, touching this point at the circumference. Now this whole angle here, it's what? It's 90 degrees. Sorry about that. This angle here, which is A1 plus A2, is equal to 90 degrees. Y angle at semicircle, sorry, semicircle, just a diameter. We found something from there. And then now coming to the statement where it's saying a chord CA, this is C, it's saying CA intersect a radius, which radius OD at point at E. OD at point E. What does that mean? Now we have this chord which is CA, and we also have this radius which is OD, but they intersect here. What we see here, that UC, UA, E is going to be equal with what? With UC, E. Why? A line from a center, this line from a center, it's going to be perpendicular with this chord from theorem number 1. Line from the center, line from this center going, it's perpendicular to which? This line here. So this makes this equals to this. What's the reason? A line from center perpendicular to what? To a chord. And then now if this one now is equal to this one from theorem number 1, then let's make this one now what? Being 90 degrees. So this making what? E2 being what? Being 90 degrees. Why? A line from a center to a midpoint chord, because now this chord, now this one is equal to this one, so making this angle here 90 degrees. A line from a center to a midpoint. This midpoint is a midpoint now because we have proven that UCE is equal to UCA, so we know that is a midpoint. That's why it's to E2 it's 90 degrees, because a line from a center to a midpoint chord. We know that one now. Then continue with our statement. AB is grown. This is AB, which is just another chord. This is B. Sorry guys, this is just B. And then now they are going to say CD, which is CD. This CD, it's parallel to what? To OA, to this OA here. It's parallel to that one. This is E, guys. This is E. This is supposed to be, your paper is supposed to be like this. And then now if it's parallel, there are three things in parallel lines. There's alternate, there's cointerior, there's corresponding angles. From this one here, there's always a Z shape. Now Z from here going here, going here, going here. What does that mean? It's telling us that angle D, which this angle, because it's alternating there at these corners, D is equal to what? O1, which is just alternating angles. Why they're alternating? Because you see D is parallel to what? To OA. And then also coming to this side now, where it's zoo, zoo, zoo. Now we know that to A2 is equal to what? To C1. It's also alternating angles. Why? Because CD is parallel to O. Okay. And then now I hope you're gonna see an F shape. F shape, where is this one? This F shape here, where this now is gonna be equal to this one. I hope you see that one, where O2 just gonna be equal to C1 plus C2, which is just what? Corresponding angles. Corresponding angles. Why? Because you see D is parallel to OA. I hope you're seeing that one. I hope I don't miss anything from here. Then now when they're saying now A2 is X, so A2, this angle here, it's what? It's X. This angle here, it's X. So just gonna correspond anything with A2 to make it X. So here A2 was equal to C2, meaning it's equal to X also. And then now we know here this A2 it's X also, and here we know A2 it's gonna be X, which is C1 is gonna be equal to X also, from just our statement, just analyzing everything that we got from what? From our statement. I hope you see the importance of just analyzing what? A statement. Now we're gonna move on to the questions. We're gonna move on to questions and see that everything that we wrote here is gonna be one of our answers in the question. This thing, to master it, practice, guys. Going to the questions now. The question is saying, give reasons why. Give reasons, with reasons why C1 is equal to X. They told us that A2 is equal to X, so we know A2 is equal to X, so everything has to be connected with A2 being X. So they are saying, with reasons, tell me why C1 is equal to X. From the things that we have done during analyzing our diagram, we know that A2 is equal to C1, where A2 is equal to X. From what we analyzed before coming to the question. So now from here, solutions. Number one, way to C1, we know is equal to X. Why? Because it's equal to A2. Reason, alternating angles where CD is parallel to OA. From our analysis, from our data that we collected from this statement and this diagram. There's nothing new now. Number two, they are saying C2, why C2 is equal to X. C2 coming here, A2 is equal to what? C2 is equal to OX. So now the important thing is, before we came here, this was the first thing that we needed to write. So about that one, this was the first thing that connected us to whatever that we wrote here. So I think it's very important to say that OO, which is OO A is equal to OOB is equal to OC is equal to OD. These are ready before you're gonna state that C2 is equal to OX, because it's equal to OA2. Why? Because opposite angle is opposite equal side. Which triangle is this one? C2, which is this triangle here, which OA is equal to OCB, which is that triangle. And now done with this question. Now the following question from this one is this one, where now they are saying let's calculate the size, determine the given reason why the size of the following angles in terms of X. So we need to calculate the following sizes in terms of X. So we need to do this question in terms of X. Now they are saying we must first do A1. solution. Okay, in terms of x we need a1. From here we know that a1 plus a2 is equal to 90 degrees angle at a semi-segment. a1 plus a2 is equal to 90 angle at semi this is semi-circle, not semi-segment, sorry guys, semi-circle. But we know that a2 is equal to x, this is 90, then this is a1, so a1 is equal to 90 minus x. They are looking at our answers in terms of x, our angles in terms of x, so this is just number 1. Then number 2, they are saying we must what is what a1, what is what a1. Now o1, they are o1 not a1, o1 is equal to 2 times bani c1, angle at center twice the angle at the circumference. This angle here is twice the angle that is here from our analysis in our diagram. So we know that o1 is equal to 2 c1, angle at center is equal to 2 times the angle at the circumference, and we know that c1 from what we did here is equal to what, x. So o1 just equal to 2x. I hope you see guys, it's very important. And then number 3, they are saying this must look for ubani o2. We must look for o2. Then o2, from what we have here, o2 is equal to c1 plus c2, where c1 it's x and also c2 is x. So we know that o2 is equal to c1 plus c2 y, corresponding angles. Now there's no need of going to the diagram trying to look and make everything, because we're just taking from what we've collected, what we have did already. We know, we're just taking it from our analysis here, our data that we have collected. So now o2 is just equal to x plus x, which is just 2x. I hope you see guys. Then o2 angle corner is just equal to what? It's just equal to x, just equal to x. Thank you so much guys. The last question of this video is this one, where now they are saying for which values of x, which value, not values, for which value of x will, if now a, b, o, e be a cyclic quad. Now if now a, b, o, e, this part here, it's what? A cyclic quad. What will be the x? Now what is a cyclic quad? We know that cyclic quad, 2 opposite angles of the cyclic quad add up to 180. So o1 plus o2, which is this one angle as a whole here, masihlanganisa now with a1 plus a2, which is this whole angle here, which is angle A, is equal to 180. Why? Because opposite angles of cyclic opposite angles of a cyclic quad. Now this whole angle here, O1 and O2, it's just O1, we know that O1 is 2x, we know that O2 is also 2x, we've already calculated it. And then now this whole angle here, which is O1 plus O2, we know it's 90 degrees. We have already calculated angle at the semicircle, sorry guys. 90, this is 180 is equal to 180, and then this is just 4x, so it's just going to be 4x is equal to 180 minus 90, which is just 90. Then we divide by 2, divide by 2. Our x is just going to be 2, 5, which is 90 divided by 2. I divide by 4, sorry guys, divide by 4, it's 4 divided by 4, which is just 2,5, which is the value of x that we are looking for. Thank you so much guys for watching. Thank you so much.